A Python list is like a row of boxes on a shelf. Each box can hold a toy, a word, or any object. Creation: you can line up the boxes by writing them inside square brackets. My boxes equals apple 3. Each item gets an index that starts at 0, the first box, then 1, 2, and so on. Print my boxes 0 prints apple, print my boxes 2 prints true. Negative indexes count from the right side, just like saying the second box from the end. Print my boxes -1 prints true, last item. Slicing lets you take a slice of the row, like cutting out a sub-row of consecutive boxes. The syntax is list start stop step nums equals 0 1 2 3 4 5 6 print nums 2 to 5 prints 2 3 4 print nums up to 3 prints 0 1 2 from start to index 2 print nums every second prints 0 2 4 6 every second box. Traversal means walking through each box one by one, usually with a for loop for item in nums print item. Think of it as reading every word on a list of flashcards. Explanation: lists are mutable, meaning you can change the contents after the list is created, just like rearranging toys on the shelf. Append item adds one new box to the right end. Words equals list of cat and dog. Words.append mouse. Extend iterable opens many new boxes at once, copying all items from another collection. Words.extend list of bird and fish. Insert index item puts a new box at a specific position, shifting the others to the right. Words.insert one hamster. Pop optional index removes a box and gives you what was inside. If you omit the index, it removes the last box. Last equals words.pop. Second equals words.pop1. Remove value finds the first box that matches the value and throws it away. Words.remove dog. Clear empties the whole shelf, leaving an empty list. Words.clear. In place assignment, you can replace a slice with new items, changing many boxes at once without creating a new list. Nums equals list 0 1 2 3 4. Nums slice 1 to 4 equals list 10 20. Now nums is 0 10 24. All these operations happen inside the same list object, so any other variable that refers to the list sees the change. Python ships with a toolbox of functions that make a list behave like a smart assistant. Aggregation, getting a single summary number from many items. Len LSD, how many boxes. Sum LSD, add all numbers together, works only if items are numeric. Min LSD, max LSD, smallest and largest values. Searching, finding where something lives. Item in LSD returns true if the item appears anywhere. LSD.index value gives the first index where value occurs, raises value error if not found. Sorting, arrange boxes from smallest to biggest, or any custom rule. LSD.sort sorts the list in place, like reorganizing the shelf. Sorted LSD returns a new sorted list, leaving the original untouched. You can pass reverse equals true to go descending, or give a key function to decide the ordering. For example, sorted words key len sorts strings by length. Reversing, flip the order. LSD.reverse in place reversal. Reversed LSD returns an iterator that yields items from right to left. All these helpers are O of n for a list of length n. They need to look at each item once, except list.sort, which typically runs in O of n log n using timsort. A list comprehension is a compact way to build a new list, like a magic recipe that takes ingredients an existing list and produces a finished dish. Basic syntax: new list equals open bracket expression for item in iterable close bracket. The expression tells what to put in each new box, while the for part walks through the old boxes. Example: dash square numbers 0 to 4 squares equals open bracket x times x for x in range 5 close bracket hash 0 1 4 9 16. Conditional filtering lets you skip items that do not satisfy a test, like only keeping the even toys : evens equals open bracket x for x in range 10 if x modulo 2 equals 0 close bracket hash 0 2 4 6 8. You can also put a condition inside the expression to change the value : Desker equals open bracket even if x modulo 2 equals 0 else odd for x in range 5 close bracket hash even odd even odd even. The power comes from readability: one line replaces a multi-line for loop and an if statement, yet it is still clear what happens. Explanation: when data lives in a table or a matrix, rows and columns, You can use nested list comprehensions, a comprehension inside another, to generate two-dimensional structures. Creating a multiplication table, size n. N equals 5. Table equals open bracket I times j for j in range of 1 to n plus 1 close bracket for I in range of 1 to n plus 1 close bracket. The result is a 5 by 5 multiplication table. First row 1, 2, 3, 4, 5, second row 2, 4, 6, 8, 10, third row 3, 6, 9, 12, 15, fourth row 4, 8, 12, 16, 20, fifth row 5, 10, 15, 20, 25. The outer comprehension iterates over rows. The inner one builds each row by iterating over columns, j. Flattening a matrix, turning a 2D list into a 1D list, uses two loops in one expression. Flat equals list comprehension of elim for row in matrix for elim in row. Mathematically, if A is a matrix a sub ij, flattening produces the sequence O11, a 1-2 through a 1n, a 2-1 through a mn. You can also add conditions to both levels. For example, keep only even products. Even table equals open bracket I times j for j in range of 1 to n plus 1. If I times j modulo 2 equals 0 close bracket for I in range of 1 to n plus 1 close bracket. Nested comprehensions are a clean way to work with any number of dimensions. Explanation: understanding time complexity helps you predict how fast a list operation will be as the list grows. Indexing open bracket LST left bracket I right bracket close bracket is big O of 1, instant lookup. Append is big O of 1 amortized, occasionally big O of n when Python resizes. Insert /pop at front is big O of n must shift all items. Search in comma index is big O of n may look at every element. Sortlist.sort is big O of n log n. Because lists store elements contiguously in memory, they are fast for random access but slower when you need to insert or delete in the middle. Generator alternatives - if you only need to iterate once over a huge sequence. A generator expression saves memory because it yields items one by one instead of building a full list. Big equals open parenthesis x times x for x in range 10 million close parenthesis, which is a generator, no big list stored. Then for each val in big, if val greater than 1 million break. When the dataset does not fit in RAM, consider using itertools utilities such as isList or chain, processing data in chunks by reading a file line by line, and leveraging array.array or numpy arrays for homogeneous numeric data, which use less overhead per element. NumPy is a library that provides arrays, a compact, fast representation for large numeric collections. Converting between Python lists and NumPy arrays is a common step when you need heavy math. Import numpy as np, pylist equals 1, 2, 3, 4, r equals np.array of pylist, comment dtype inferred as int64. Back equals r.tolist, comment 1, 2, 3, 4. Once you have an array, you can perform vectorized operations without explicit loops. R times 2 gives array of 2, 4, 6, 8. R plus numpy arrange 4 gives element-wise addition resulting in 1, 3, 5, 7. Mathematically, if V is a vector list, and C a constant R times C computes CV for all components simultaneously. Matrix equals list of list 1, 2, 3, and 4, 5, 6. npmat equals numpy.array of matrix. Shape is 2, 3. NumPy arrays use contiguous C-style memory, which is far more space efficient than Python list of lists, and enables fast linear algebra routines such as dot product and matrix multiplication. Real-world scenarios where lists shine. 1. Data parsing. Suppose you read a CSV file line by line. Each line is split into fields and stored in a list for later processing. Rows equals an empty list, with open grades.csv as f:. For each line in f:, rows append line strip split comma. 2. Filtering pipelines. Imagine a list of usernames. You want only those that start with a and are longer than 3 characters. Good equals list comprehension of u for u in users if u dot starts with a and length of u greater than 3. 3. Generating combinatorial structures. Create all possible 2-letter codes from the alphabet. Import string. Codes equals list comprehension of a plus b for in string.ascii underscore uppercase for b in string.ascii underscore uppercase. Comment 26 times 26 equals 676 codes like a b, and so on. 4. Cartesian product for scheduling, pair each day with each available room. Days equals list of Moan, 2. Wed rooms equals list of 101, 102. Schedule equals list comprehension of tuple d, r for d in days for r in rooms. These examples demonstrate how lists and list comprehensions let you collect, transform, and generate data in an intuitive step-by-step fashion that mirrors everyday tasks such as sorting cards, building a Lego set, or preparing a recipe.